Let's talk a little bit about antenna capacitance. Since the coil wants to see a certain kind of capacitance, a certain value of capacitance, a certain range of capacitance hanging off of it and going to ground in series with it to oscillate well, we need to understand the capacitance that it sees. And that capacitance is obviously the Theremin antenna. You know, it's weird, but it's true that a piece, something that's conductive like this, just hanging out in outer space or here or wherever, is interacting with the rest of the universe and acting like a capacitor. So this is like maybe 15 picofarads, just being like it just is, sort of, which is weird. So that's what we call intrinsic capacitance. It forms a capacitor with the rest of the universe. And the coil then, when you hook this plate up, the coil thinks it sees like, well, it knows that it sees like, 15 picofarads to ground, and then it can oscillate well, and the plate can oscillate well, and everybody's happy. So the surface area of the Theremin antenna is critical to the proper operation of the oscillator. If the intrinsic capacitance is too low, the oscillator will have difficulty, stability difficulty. The D-Lev oscillator won't stall, but it will have stability issues with very low intrinsic capacitance antennas. So if you have like a thin wire for the antenna, it will work, but it's kind of asking for it because the capacitance is too low, and you want to hit that good spot. And you might think, well, maybe I can just take a 10 picofarad capacitor and hang it off the coil and ground that, and then get my stability. Well, you would end up with a very stable oscillator, but then the interaction with your hand is in parallel with that, and then so you're reducing the sensitivity quite a bit, and so you'd have to increase the sensitivity, and then you're back to a noisy situation. So you can't do that. You have to have a good intrinsic capacitance antenna to begin with for everything to be optimal. And Theremins are just kind of a problem looking for a problem. They're extremely sensitive devices operating in very polluted environments, and very polluted electrical environments. So we need to help them out all we can. So that's about it for antenna capacitance. Oh yeah. I want to talk about the two different kinds of capacitances. So there's intrinsic capacitance, which it just has with the universe, and that's based on its area. And then it has a mutual capacitance with your hand. So as capacitor is generally like two plates, and with a Theremin, one plate is your hand because you're grounded, more or less, and then the plate is whipping around, and so when they're near each other, they form a mutual capacitance. So there's intrinsic capacitance the plate has all by itself, and then there's this mutual capacitance. And as your hand gets closer, the bulk capacitance, the intrinsic and the mutual together increase. So the closer you get to the plate, the more the bulk, the capacitance that the coil sees increases. It's true that, I didn't know this until I was doing finite element analysis of capacitance of various objects, that the intrinsic actually reduces as your hand gets near the antenna, but the mutual increases at a faster rate, so that overall, you get a capacitance increase as your hand approaches the antenna. So that's mutual and intrinsic capacitance.